Hello everyone, I am Hằng. Today I will talk about the rotation in the motion of rigid body. In this video, I will talk about the angular velocity and angular acceleration. I immediately move to that slide. It's right here. So in the previous video, I explained about rolling without sliding already. And I have a relationship between the linear distance s here and the distance on the wheel like this. So s equal r times 2 delta theta. Remember, we consider rolling without sliding, so we have that relation. If rolling with sliding, so we don't have this relation, okay? So now, to calculate the angular velocity, I start from this relation between the linear distance and the distance on the wheel related to the angle like this. So we start from here. Now I take the derivative both sides of the equation. So I take the derivative of s with respect to time. So I have a velocity. But later I will talk about it. Let's talk about this one first. R here is the distance, the radius of the wheel. In normal condition, so the radius of the wheel is a constant during this process. So I take the radius out from this derivative of with respect to time. So I rewrite it like this. And then remember, if you take the derivative of distance with respect to time, so you have velocity. And r is a constant. I rewrite it. If you take the derivative of angle with respect to time, so you have the angular velocity. So here is the relationship between angular velocity omega and linear velocity v. Take a look on the unit. If you consider linear velocity v, so the unit is meter over second. But if you consider the unit of omega, the angular velocity, so it will be radian over second. Remember, like the units, we work in SI units, okay? Here is the magnitude of velocity. As you know that velocity, we also have, relating to velocity, we also have a direction. So how do you define the direction? If you want to define the direction of velocity, so this one is the relation between the omega and the radius to have the direction of velocity. Here I present the example for the direction. I suppose that I have a vector r here, up like this, up, okay? When I consider, and then the direction of angular velocity is in, from out go inside, go in. So here you see cross, okay? So how do you define the direction of velocity? So as I said before, here you have a cross product. So to define the direction of the result, you have many ways. One of them is the right hand. You use your right hand. The first vector, you put it along the omega. The second vector, you put it, the first vector, here I have my right hand, and I put like this. The first vector is along the omega, so I have to put my finger in. The second vector is up, so I have to put my, so from here in is the omega. From here to the wrist, so the vector r, and the result vector is the thumb. So vector velocity have to be to this direction. It's like this. That is okay. Now I just talk about the angular velocity and the relationship between linear velocity and angular velocity. Now we move to the next one, angular acceleration. So I start from here, this relationship, I rewrite it right here. Now I take the derivative both sides of the equation. So I do like this. One more time, the radius of the wheel is constant, so I take it out from this formula. So I have this one. Now remember, if you take the derivative of velocity with respect to time, so you have acceleration, and the radius, you rewrite it here. Here is the change of angular velocity with respect to time, so you have angular acceleration. Therefore, this one is the relationship between the tangential acceleration, linear acceleration, with the angular acceleration. Here is the relationship. What is the unit of tangential linear tangential acceleration? It will be meter, the unit of velocity over the unit of time, and the unit of velocity is meter over second. Now you divide by second one more time, so you have a meter over second square. The same, how do you define the unit of the angular acceleration? It is the unit of angular velocity divided by time, and the unit of angular velocity is radian over second. And one more time, you divide by second, so you have a radian over second square. Here is the unit of the angular acceleration. So I have the relationship between linear acceleration, tangential acceleration, and angular acceleration of a point here, for example, here for example. Okay, and relating to the direction, so we have this relationship between linear acceleration and angular acceleration. Okay, so conclusion for this half of the slide is the formula for angular velocity and the formula how to calculate the angular acceleration. This one actually instantaneous. If you consider the average, so here you have delta t, and here also, now you don't take the derivative, don't take the derivative anymore, you divide. Okay, and next you have a relationship between linear velocity and angular velocity, as well as tangential acceleration and angular acceleration. Here I make the conclusion here. Here is the relationship between the angular position and the distance. It's like this. So how do you calculate the, based on the angle, how do you calculate the angular velocity? You do by this way. And here you have a relationship between the distance and velocity. You know this one in the lecture 1, kinematics already. And here, if you have a linear velocity and you have an angular velocity, so you have a relationship between the relation between them, like this. Next, when you have a angular velocity, you can calculate angular acceleration by this formula. Actually, here I give you two formula. The first one is instantaneous. The second one is average. And I explained the difference between instantaneous and average in the previous videos. So now I don't repeat it. If you forget it, so you watch again yourself. If you have velocity, you can calculate the linear acceleration by this way. And now you have a relation between tangential acceleration and angular acceleration by this way. So this one nearly the summary of this slide. So I will stop here. See you in the next video. Thank you for watching.